Nehemiah Grew, 1641–1712, is best remembered for his careful and novel observations on plant anatomy, for his role in the development of comparative anatomy and as one of the first naturalists to utilize the microscope in the study of plant morphology. His most lasting work, containing his observations and impressive illustrations, is most certainly his early work published in 1682. Although Grew continued to publish throughout his life, especially on the chemical properties of various substances, all but the anatomy have fallen into obscurity. Grew was a doctor by profession, receiving his degree from the University of Leiden in 1671. He was the son of a nonconformist and supporter of Parliament, who was briefly imprisoned while his son gave lectures to the Royal Society and dedicated his books to the king. Nehemiah had little of his father's political inclination, although he inherited some of the latter's nonconformist religious views. He practiced medicine in London, where he met John Wilkins, 1614–1672, one of the founders of the Royal Society, who was likely attracted by the younger man's opinions. Wilkins was impressed and he recommended Grew to the Royal Society for membership. Grew later served as secretary to the Society, along with Robert Hooke, 1635–1703, the infamous virtuoso and inventor. Like Hooke, Grew utilized the microscope for his investigations into plant anatomy. Along with Marcello Malfighi, Grew is remembered for establishing the observational basis for botany for the next 100 years. As Grew acknowledged, Wilkins' encouragement was crucial to his work, both intellectually and financially. Having been made a member under Wilkins' influence, he was engaged by the Royal Society at £50 a year to research plant anatomy. But getting actually paid was another matter, and Grew had to plead with the Society to receive what he was due. In his later life he practiced medicine in London and Coventry. Throughout the 1670s Grew wrote short pamphlets on botany, often in Latin, and in 1680 translated and compiled them together under the title. He published a number of minor essays in the Transactions of the Royal Society, for example, the description of an hummingbird and some observations touching the nature of snow. In 1681 he published, packed full of curious observations. 1683 saw the publication of, and in 1697 his. In his last work, 1701, Grew turned to philosophy and theology in order to demonstrate the truth and excellency of the Bible. In many ways a contemporary review best sums up the significance of Grew's scientific work, since much of that significance is obscure today. In general, it is noted by our author, that it will here appear, that there are those things which are little less wonderful within a plant than within an animal, that a plant, like an animal hath organical parts, some whereof may be called its bowels, that every plant hath bowels of divers kinds, containing divers liquors, that even a plant lives partly upon air, for the reception whereof it hath peculiar organs. Again, that all the said organs, bowels, or other parts are as artificially made, and as punctually for place and number composed together as all the mathematical lines of a flower or face, that the staple of the stuff is so exquisitely fine, that no silkworm is able to draw so small a thread, that by all these means the ascent of the sap, the distribution of the air, the confection of several sorts of liquors, as lymphus, milks, oils, balsams, with other acts of vegetation, are all contrived and brought about in a mechanical way. The significance for this 17th century reviewer is the mechanical way in Grew's organism, that plants possess organs and structure. It wasn't certain before the 17th century that plants had much internal structure in which distinct parts or organs played distinct roles. It was often thought, especially during the Renaissance, that the external shape of a plant was a clue or signature to its use, but whether there was anything resembling organs in plants was contested. A generation earlier, in his 1644, Virtuoso and All-Round, Blowhard, Sir Kenelm Digby, 1603–1665, downplayed the existence of distinct organs in plants. However, Grew's detailed observations established without a doubt that plants were analyzable into functional and morphological units, reinvigorating a tradition that went back to Theophrastus. Grew is remembered for his detailed descriptions of plant anatomy, and with him we see the beginning of modern comparative anatomy. He was guided by the idea that there may be similarities of function between animals and plants, and this led him to look for equivalent organs in each. He thus believed in the circulation of sap, on analogy with William Harvey's discovery of the circulation of blood in animals, and he believed in a form of respiration in plants. Although the recognition of plant sexuality was old, Grew is remembered for noting the stamen as the male organ of the plant and pollen as seed. He also noted the prevalence of little bladders, or cells, as Hooke had coined the term, especially in the parenchyma tissue, a term we have retained from Grew. Many of Grew's observations were diachronic, putting emphasis on the development of the plant and its structures. The growth of a plant he deemed to be a function of sap circulating through the tissue, carrying and adding material to the plant. His observations on the bud of the flower revealed the complicated folding of the unexpanded leaves, something that had not been previously seen with the naked eye. Grew's mechanism consisted in his adherence to observations and his avoidance of explanations invoking vital forces, signatures, sympathies and antipathies. Also to be avoided was the direct hand, intervention, or guidance by God. Instead, the mechanist looks for natural or secondary causes for the phenomena and the laws that govern them. Grew invokes no occult or hidden forces, although he offers a great deal of wild chemical speculation in his botanical and medical studies. The mechanistic project was a deliberate attempt to offer explanations of phenomena in terms that were corporeal, material or physical, however these difficult terms were to be interpreted. The mechanical philosophy allowed the researcher to think much like an engineer, how to make available materials do the task that is desired. The engineering image was also theologically acceptable. God is the engineer who constructed the mechanisms of nature, and as such nature can be seen as artificial, the product of God's industry. As natural philosophers, or scientists, we can uncover how these artifacts are constructed and how they function, by analogy with discovering how a machine, such as a clock, is constructed and functions. Grew published his philosophical and theological views late in life. In his last book, Grew argues for a number of doctrines. He divides the natural causes within the universe into vital and corporeal components. Living and cognitive creatures have their origins in a vital principle, distinct from matter, yet bodies are necessary for the existence of life. Life, being more excellent, p.34, than mere physical motion, requires an excellent, and so a distinct subject, to which it belongs. And therefore something, which is substantial, yet incorporeal. Grew's vitalism was not uncommon for the time, especially among the doctors, and reflects the Neoplatonist heritage found in many influential naturalists such as John Ray, 1627–1705. But Grew revealed his sympathies for nonconformist religious thought in his account of miracles. Grew asserts a former deism, that once God has created the world in accordance with his laws, God has no further need to interfere. God acts through the world only through secondary, that is, natural causes, which includes the vital, incorporeal principle of life. God does not act directly upon natural events but brings them about by other natural events. Miraculous events are merely those events which are rare and for which the cause is unknown, but they are not caused directly by God. Every miracle is effected in the use of some second or natural cause, yet to make it a miracle, it is requisite that this cause be unknown to us. p. 195. The denial of miracles supports Grew's dominant theme, that the universe reveals the existence and wisdom of God in its design and structure. The deist view sits happily with mechanist perspective. Everywhere a doctor looks he can see the remarkable living machinery of the body, how organs grow to their proper and useful places. Grew took it that the teleological features of the universe revealed the wisdom of its construction. The idea was an old one but had recently gained ground in Robert Boyle's discussion. Grew was not as careful as the skeptical alchemist and saw many of the world's wonders as designed for the sake of man, although he took it that the internal structures of plants were for the benefit of plants. The incredible usefulness of the cocoa plant, the silkworm and of iron, indicate that the universe is well suited to mankind. But the argument from design is often ridiculed as an argument from poor design, when one reflects on the hardships of life and the immorality of men. Grew is not daunted by such reflections. The most exorbitant fancies and lusts of men illustrate the beauty of God's creation. One man makes all his thoughts and pleasures to center in meats and drinks, another, in music, a third, in women, or some other sense or fancy so as to think of nothing else. Which, as it shows the infirmity of human nature, so the plenitude and perfection of the world, in being fitted, so many ways, to beatify men, would they know discreetly how to use it. And the same lust and fancies are many other ways turned to good. Grew made his observations independently but simultaneously with Marcello Malfighi, in what might be considered a case of independent co-discovery, an interesting phenomenon in the history of science. Most famous is the co-discovery of natural selection by Charles Darwin and Alfred Wallace. But if Grew and Malfighi's work counts as co-discovery, it is in a very different way from that of Darwin and Wallace. Arguably, the co-discovery in plant morphology was a result of technological advances due to the invention of the microscope and was somewhat non-theoretical. Darwin and Wallace, however, discovered a law of nature, making significant theoretical advances in addition to their remarkable observations. But of course, without the meticulous work by the pioneers of botany, fruitful theory would not have arisen. Thus Nehemiah Grew must be remembered for his pioneering role in the establishment of modern botany.